Everyone, welcome to my channel Origin One. In today's video, we explore a very important concept of operating system, the process control block or PCB. Before we jump into the PCB, let's quickly understand what a process is. A process is basically a program in execution. It's more than just a code. It includes data, state, program counter, CPU, register, all working together while the process runs. Your computer may be handle hundreds of programs at once. Let's start. Process control block. A process control block is a data structure used by the operating system to store all the information about a process. It is crucial for process management, containing details such as process state, program counters, CPU register, and memory management information. Definition of PCB. What is process control block? The process control block is a fundamental data structure that contains all the vital information about a process, enabling the operating system to manage processes effectively. Means to manage all these processes effect efficiently, the operating system needs a way to keep track of them. That's where the process control block comes in. The PCB is like an identity card or a profile of a process. It stores all the essential information that the OS needed to manage the process. Each process has its own PCB. Purpose of PCB. The PCB serve as a repository for and process-related data, facilitating the scheduling, execution, and termination of a process within the operating system. Importance in OS. Let's summarize why the PCB is important. It allows the operating system to switch between the process efficiently, ensuring that each process has the necessary information to resume execution accurately. Without it, the OS would not know what a process is doing. It helps with multitasking, scheduling, resource management. It ensures reliable and accurate switching between tasks. In short, the PCB is the backbone of process management. Components of PCB. Let's break down what a typical PCB contains. Number one, process state. The PCB includes the current state of the process, example, running, waiting, ready, and others, providing the OS with insight into the process's status. Number two, program counter. This component keeps track of the address of the next instruction to be executed, allowing proper execution flow when the process resumes. Number three, CPU registers. The PCB stores the value of CPU register for the processes, ensuring that the register states are preserved across context switches. Memory management information. This includes details about the process memory allocation, such as page tables and segment tables, which are crucial for memory access. There are other some components of process control blocks are process ID, a unique number of each processes, accounting information, CPU usage time, process priority, etc. Input output status, what a file or a device the process is using. In the next page, there is the structure of process control block. In the previous slide, we discussed about the components of process control block. In this slide, we discuss about the structure of process control block PCB, which contain process ID, PID, process state, process counter, process number, register, memory limit, list of open files and others. Before we moving on the next slide, we're discussing about PCB and context switching, where the PCB play a crucial role during context switching. Imagine two processes, process A and process B. If the CPU switches from A to B, it must save as state and later restore it. This saving and loading of state is done using the PCB. PCB is also important in multitasking, scheduling, and resource management. Process scheduling. Role in scheduling. The PCBs plays a critical role in process scheduling by maintaining information need to prioritize and select the processes for execution. Context switching. During a context switching, the operating system saves the PCB of the currently running process and load the PCB of the next scheduled process, facilitating a smooth transition. Schedule algorithm. Different schedule algorithm, example round robin priority scheduling, use the information in the PCB to make decision about which process to run. PCB and multitasking. Number 1. Supporting multitasking. The PCB is essential for multitasking environment, enabling the operating system to manage multiple processes simultaneously and efficiently. Number 2. Isolation of processes. Each process has its own PCB, which helps isolate processes from each other, enhancing security and stability in the system. Number 3. Resource allocation. The PCB contains information on the resources allocation for each process, ensuring fair distribution of CPU time, memory, input, output devices. PCB in different operating system. Number 1. Windows operating system. In Windows, the PCB is the part of the kernel's data structure which manages threads and processes, providing a detailed overview of their states. Number 2. Unix and Linux system. Unix-like system utilize the PCB concept as the part of the process table, storing critical information for the process, scheduling and management. Real-time operating system. In the real-time operating system, the PCB must support timely execute guarantees, often containing additional data for priority management. PCB and process creation. Process creation. When a new process is created, the operating system allocates a PCB to hold its information, initializing various fields to their default values. Fork mechanism. In Unix-based system, the fork system calls creates a new process with the separate PCB, duplicating the parent process attributes. Process termination. Upon process termination, the PCB is deallocated and the resources are freed, ensuring no memory leaks occurs in the operating system. Let's take real world example. Think of PCB like a resume or a file folder for each worker process. In an office, the CPU, the manager OS, uses the file to know who's working or what what their tools are and when to assign tasks. Lose the file and the manager is lost too. Challenges with PCB scalability issue. As the number of processes increases, maintaining and managing a large number of PCBs can lead to perform bottlenecks. Memory overhead. Each PCB consumes memory space and excessive PCBs can lead to increased memory usage, impacting overall system performance. Synchronization. Managing access to shared resources among multiple PCBs can introduce complexity and require synchronization mechanism to prevent conflicts. Future developments in PCB management. Advancement in virtualization. Emerging virtualization technologies may change how PCBs are managed. As a virtual machine may require separate PCB-like structure. Number second, integration without cloud computing. As the cloud computing grows, PCB may involve to manage process across distributed system more efficiently. Enhanced security feature. Future PCBs could incorporate better security measures to protect processes information from unauthorized access and ensure data integrity. PCB in process life cycle. Processes are involved in every stage of processes life cycle. Create. A new PCB is created when the process is created. Running. The process control block is continuously updated. Waiting. Process control block shows that it's waiting for input output. Terminated. The PCB is deleted when the process ends. Before we moving forward to the conclusion on the PCB importance, let's recap quickly what we understand and study about the PCB in this video. What is process? Program in execution. What is PCB? Process control block. The data structure that holds all the process information is called process control block. Where it is used? It is used in context switching, scheduling, and resource tracking. Quick question. Which part of PCB holds the last executed instruction? The answer is the program counter. Let's conclude it. Conclusion on PCB importance. Summary of PCB importance. The process control block is a vital component of operating system, essential for process management, scheduling, and resource allocation. Impact on system performance. Efficient management of PCB directly affect the performance and responsiveness of the operating system. Future trends. The evolution of PCB will continue to play a crucial role in the advancement of operating system technology. Thank you for watching. If this helped you understand the process control block, please give the thumb up and consider subscribing for more OS content. Drop your questions in the comment below and I will see you in the next one. Thank you.